So example 10 says find the missing sides of this triangle, and you'll notice yesterday we did the Pythagorean theorem. We had a right triangle, we knew two sides, right? And I said anytime you know two sides in a right triangle, you can use the Pythagorean theorem to find the third side. Okay? How many sides do we know on this triangle?
One.
One. All right, so we don't have as much information, but what I do know about this triangle is that we have a 45-degree angle in the corner, and it is a right triangle, so we know two of the three angles. So if I subtract from 180, 180 minus 90 minus 45 makes the other angle 45 degrees. That does make this an isosceles triangle, and because these angles are the same, these sides are the same. So if this is 7, this is also 7. So that's one technique for figuring out the missing sides in this picture. And if I go with that technique, I know that's 7, I know A is 7 because of the isosceles triangle part of it. Now I've got enough information with the Pythagorean theorem to find B. I can say B squared equals 7 squared plus 7 squared. So B squared equals 49 plus 49. So B is equal to 98. B squared is 98, thank you. B squared is 98. And that's how the Pythagorean theorem works. And then when we get to this point, we're going to square root both sides. And my calculator says the square root of 98 is approximately 9.899. So B is approximately 9.899. So just like that, we get A is equal to 7, B is 9.899. We found our missing sides. And again, I said that is one way to find the answer to this problem. The other way to do this problem that's more typical is using similar triangles like this. Every 45, 45, 90 triangle in existence is similar to that one over there. The side measures are 1 and 1, and the legs and the hypotenuse is the square root of 2. And using similar triangle ideas, which you would have learned about in geometry, this vertical side corresponds to this vertical side. This horizontal side corresponds to this horizontal side, and this hypotenuse corresponds to this hypotenuse. Okay. When you put dashes, you're saying they're the same measure. When you put the squigglies like that, you're saying they're proportional to one another. And it would look like this if I was creating a proportion. I'd make a fraction 1 equals fraction 2 equals fraction 3. I would put the measurements from one triangle on top, and I would put the measurements of the corresponding pieces below each of those sides. So A over there in that triangle corresponds to 1 in this triangle. 7 in that triangle corresponds to 1 in this triangle. B in that triangle corresponds to the square root of 2 in this triangle. Okay, so you make this proportion. Everything from your triangle goes on top, and these magic numbers go on the bottom, 1, 1, square root of 2, in order of correspondence. And then you simply do one proportion at a time. I take this proportion here, and I cross multiply A times 1 equals 1 times 7. I would do this proportion here. B times 1 equals 7 times the square root of 2. Which, if you get your calculator out, 7 times the square root of 2 is 9.899. So, if you just commit this triangle to memory, 1, 1, square root of 2, that's how you get a 45, 45, 90 solved anytime you need it. Okay. As long as you know one side and it's a 45, 45, 90, the proportion works. My advice for ease of work and in getting everything neat and organized, if I put my unknowns on top and I make sure the one I know goes in the middle. Something I don't know, something I know, something I don't know. That way I've got these two on this side, make one cross multiplication, these two on the other side do also. So it just makes it a little bit easier to go through my work and make it nice. That would be the technique I'd want you to use, but again, in a pinch, it's a test, I can't remember the numbers. You can use the fact that this is an isosceles triangle to get that. Pythagorean theorem finds that. It would work. Okay. in that I can't remember the numbers, and let's say we know the hypotenuse, just in case that should happen to you. So let's say I got a 45, 45, 90 again. And let's say I know the hypotenuse is 14, just to give it a number. And this is a 45-degree angle down here, and this is what we have a right angle there, so we know this is 45. So again, we don't know either side, right? But I know that these are going to be the same number, so these are going to be equal to each other. So even though I don't know either side, their measurements are the same number. So again, even though I don't know two sides, since I'm using the same letter to represent two things I don't know, the algebra still works. Leg squared plus leg squared equals hypotenuse squared. X squared plus x squared makes 2x squared. Divide both sides by 2, and then you take the square root. Just happens to be the same number. Lucky me. So again, if I punch in square root of 98 again on my calculator, it's going to say the same thing, right? So again, even if you don't know the hypotenuse, don't know the legs are the same number, so you can use the same letter to represent. Do a little bit of algebra, divide by 2 to get the x squared equals, and then take the square root. That is legal, it would work. So again, I'd rather you go with this technique, because again, for the 45, 45, 90, this is the only one where that little Pythagorean theorem trick works. There's several special triangles I want you to focus on, so doing it that way, just so that both are done the same way, is probably better math. So there you go, two techniques to do the same problem.